All right, folks, happy Friday for you. We're looking at combustion and single replacement reactions here. All right. So when we see combustion reactions, the big thing that you're going to notice here is that there's O2. All right. For us, we're going to use what we call hydrocarbons here. All right. So hydrocarbons then are basically a hydrogen and a carbon. Now, we have that and that, right? So when we do these, remember we're going to get CO2 and H2O every time. Now, the nice thing about getting CO2 and H2O every time is that we can balance that carbon first, that hydrogen second, and then use that oxygen at the end to try and balance those with this, okay? So hydrocarbon. In this case, we have a benzene, so we have C6H6 plus O2 yields carbon dioxide and water. Here we have some carbon, I don't know what that is, some hydrocarbon plus oxygen yields that. Another one right there, another real funky looking hydrocarbon there, right? For us now, keeps houses warm, that's going to be propane, C3H8. Keeps cars moving, that's going to be ethanol, right, as we see it, or unleaded gasoline is going to produce this carbon dioxide in that water. All right, so anytime that we have this as our hydrocarbon and our O2 there as well, what we're going to see is we're going to produce carbon dioxide and water. Pretty straightforward. Okay, so again, combustion reaction. If we're trying to balance this thing, we got a C, we got a H, we got an O, got a C, we got a H, we got an O. Sorry, let me put that in a little better spot. All right, so I got 4, 8, 2, I got 1, I got 2, I got 2 oxygens there, 1 there, so that's 3. Again, grossness, I'm not going to mess with that, right? So times 4 equals 4. I'm going to put a 4 in front of there. No, I'm not messing with the oxygens at this point in time. Okay, so don't even look at them in a combustion reaction. All right, H, I got 2. I need 8, so times 4 equals 8. All right, remember, I'm going to put what I multiplied by in front of here. All right, so now to look at my oxygens. All right, I got 2 there. I got a 4 there, so I got 8 O's there. All right, here I got 1 times 4. I got 4 O's there. So I got 12 O's altogether. Times 6 here equals 12. I'm going to write my 6 right there. Okay, next one. C has 6, H has 12, O has 2. Again, C has 1, H has 2, O has 3. All right, so times 6 equals 6. So I put a 6 in front of there. Again, don't care about the oxygen. All right, hydrogen, I need times 6 equals 12. All right, that's a big one. So that 6 goes there. All right, 2 times 6, that's going to be 12 O. 6 times 1 will be 6 O's. Those two added together, I've got 18 O's there. All right, this one's got to be times 9, gets me 18. Right, so I'm going to put that 9 right in front there. 9 times 2 gives me my 18. C3, so 3 C's, H is 8, O is 2, C is 1, H is 2, O is 3. All right, so times 3 there gives me 3. Put that in front of that one. Don't care about the oxygens, right? Need 8, so I'm going to multiply this hydrogen by 4. That'll give me 8, so I put a 4 there, right? 3 times 2, that's 6 O's. 4 times 1, that's 4 O's. Add my O's together, 6O plus 4O. That's going to be 10 O's. So that'll be a 10, right? To get it up to 10, I'm going to multiply this side oxygen by 5. That equals 10. So that's going to be 5 there. All right, here we go. Last one. C9, H16, O2. Separate that. C1, H2, O3. 2 plus 1. All right, so I need 9 carbons. So multiply that by 9. That messes up my oxygens. Don't care, right? Times 8 for my hydrogens equals 16. Put an 8 there. All right, so then 9 times 2, that's 18 O's right there. All right, 8 times 1, that's going to be 8 O's right there. Add those two together. I get 26 O's. Holy cow. Times 13 gives me 26. Put that 13 right in front of that O2. Boom. We are good. All right, so this one, identify if it's synthesis, combustion, or decomp, or combustion. Okay, so this one plus O2, CO2, H2O, that's combustion. All right, Li, oops, so I got 1, and then I got my plus sign over here. That's decomp. All right, got the 1 and the plus over here. That's synthesis. All right, so C8, H16O2, C1, H2O3. All right, so C's are bad, so I got 8 on the left. So multiply that by 8 to get 8 over here. Put that 8 there, don't care about the oxygens, right? Times 8 here to get me 16. Then I got the same number, put that 8 there, right? So 8 times 2, that's 16 O's. 8 times 1, that's 8 O's. So that's going to equal 24 oxygens. Whew. All right, times 12 gets me my 24. Put that 12 right up there. Bada boom, we good. All right, so then if I know what that is already, Li's got 2, O's got 1, right? Separated, Li has 1, O has 2. All right, let's go times 2 there. That gives me 2 oxygens. All right, so 2 times 1, that gives me my 2. 2 times 2, oh, that messes that up. That's got 4 now. Oh, all right, true. We in a good place then. O's are good with 2 and 2. Lithiums, I need 4, right? So I'm going to put that 4 right up there. 4 times 1 gives me my 4. And then my oxygen just needs a 1 right there. All right, let's get this last one. All right, so Ca is 1, N is 2. All right, Ca is 3, N is 2. N's are good, Ca's I need times 3. Perfect. Boom, boom. Put some 1s right there. Oh, let me make that one a little better. All right. And go 1 right there. All right. So those are combustion or decomp and or synthesis reactions. All right. Single replacement. So when we look at single, single means 1, replace means to switch, right? So we're going to have 1 element switch. All right. So as we look at this, there's your kind of generic version of that one, right? You got Fred and Wilma and Betty. Then all of a sudden, Fred and Betty and Wilma's all alone, right? This girl leaves her guy for Joe. Now Joe and Mary are happy. Poor Frank, right? You see it. All right. So when we get this one now, Na and Li are going to switch, right? The reason that these two are going to switch is because anytime we look at the front part here, that's a metal, right? And Na, again, is also a metal, right? So that Li is just a little bit more appealing of a metal, right? So it is maybe a little bit more reactive. So what we see here is that B and that A switch, right? So the B goes all by itself, and then the A is paired with the C. So with this 2 switch, and we end up with Li and NaCl. If you'll notice now, there's a plus, an arrow, and a plus. And these back here are not CO2. Oops, sorry, that was bad. CO2 plus H2O, right? All right, so single replacement reaction, A plus BC, AC plus B. BC is ionic, that's a new one. A is an element, all right? And then also B over here, B is an element as well, all right? So if we get something like this, right? A L and Mg are going to switch. Now, if A is a non-metal, sweet. How do we know it's a non-metal? When we look at that periodic table, right, and we see this staircase over here, non-metals are on the right side. So if this A is over there on that left side, like that, then we're switching the backs. Okay, again, you're not going to predict this stuff. So when we see A as a metal, aluminum, metal, Mg, metal, Cl, not a metal, right? So then what happens is our Al and our Mg are going to switch, right? So then we get Mg, metal, Al, metal, right? And then we see Cl, sorry, non, right? And then what we could do is we could balance this thing. Al's got 1, Mg's got 1, Cl's got 2, Mg's got 1, Al's got 1, Cl's got 3, right? Double my odd to get up to 6. Now, I'd love to put that down here, but I can't. I would love to put it there, but I can't. Oops, that'd still be 6. So I have to put it there. By putting it there, now I've got 2 times 3, that gives me my 6. I've also got 2 times 1, gives me 2 there. So I got to fix my AL over here, right? So 3 times 2 gives me 2, just like that would. Boom. My CL here, right? I need to get it from 3 to 6. So times 3 gives me 6. That 3 is what goes up there, right? Again, love to put it there. That looks weird. Love to put it here. Can't do it because there's an Mg. That goes there. So that's where that 3 times 2 equals that 6. Now, because there's an Mg, 3 times 1, that gives me 3 there, right? So then I got to fix my Mg over here. Holy man, folks, we're almost done. 3 times 1 gives me that 3 right there. Whew, that was a barn burner. All right, so if it's a non-metal, so non-metal, boom, right? Non-metal, boom. Na then, that's a metal right there, right? So what we see here is they're going to switch. These two are going to trade, and we get that out there, all right? So F has 2, Na has 1, I has 1. Here, F has 1, Na has 1, and I has 2. All right, well, F and F, so this would need to be times 2 to get me to 2, right? Love to put it there, can't. Love to put it there, can't, right? So I have to put it right there. So 2 times 1, that's where I get my 2 from. Now, look at this. NA's got 1 there. So 2 times 1 gives me 2. Oop, NA's are messed up, right? So multiply that by 2, right? Put a 2 in front of there. 2 times the 1 gives me my 2. But also, notice there's an I there. So 2 times the 1, that gives me a 2 there. Check it, check it. Look at that. 2 and 2. Boom, a 1 in that one. Right, my F now, I got 2 times 1. That's how I get my 2 there. Balanced. All right. So when we have this, just like we showed before, that's how we're able to balance those out. So we say that's a 2, that's a 3 from up above, that's a 3, that's a 2 from up above. We say that's a 1, that's a 2, that's a 1, that's a 2. All right, in order to get those single replacements. Why are they hard? Because out on the right side, on aka the products, we could have sneaky 7s. Again, you're not going to have to worry about them. We're going to have to balance charges in the products. Again, you're just going to have to see those formed. And sometimes reactions won't happen. Hey, we don't got to worry about that at this point in time. All right? So if we got these, all right? So here, it's a metal, that's a metal. that means that the metals are going to switch. Okay, so let's balance it. Ca has 1, Cl's got 2, K's got 1, heavy line, Ca's got 1, Cl's got 1, and what's my last one? K's got 1. All right, fix my Cl's times 2, gets me 2, right? Want to put it there, can't. Want to put it there, can't. So I got to put it there. 2 times 1, that gives me my 2. But now 2 times 1 here gives me 2 of those. All right, so I got to fix my K's over here, right? Put that there. Doesn't change anything else. We're balanced. Sweet. All right. Hey, didn't we just do this one up here? Yeah, we did. Look at that. Look at that. What's that? 2 and a 3. 3 and a 2. All righty. I like it. I like it. I like it. I like it. All right. GA. Again, metal. Oh, look at that. That's a non-metal. And that's a non-metal. So those two are going to switch. Boom. Have it. All right. F3, BR2. Heavy line. All right. GA has got 1, F, BR. That's got 2. That's got 3. Oh, all right. Let's double our odds. Right. Times 2 gives me 6. Right. Want to put it there. Can't. Want to put it there. Can't. Right. So it's got to go there. So that gives me 6. So 2 times 3 is 6. Now, 2 times 1, that gives me my 2. Uh-oh, GAs are messed up over here. Times 2 gives me 2. Put that in front. 2 times 1 gives me my 2. But also 2 times my 3 gives me my BR of 6. Oh, look at that. All right. So F, I got 6 on the left, but I got 2. 6 on the left, 2 on the right. Multiply that by 3 gives me the 6. I'm going to put that 3 there, right? 3 times 2 gives me my 6. My BRs are messy, times 3, right? Because I want to have 6. Gives me 6. Put a 3 there. 3 times 2 gives me 6. Folks, we are balanced. All right, I think you've done enough balancing stuff, so we're good. All right, summary of reactions. So if we get a plus, arrow, and then 1, that's a synthesis. All right, 1, sorry. Oh, that was terrible. Oh, gosh, folks. Run out of juice, right? 1, arrow, plus, decomp. All right, hydrocarbon, oxygen, that's a big one, right? CO2 with a plus, right? That's combustion. All right, we got a plus and an arrow, and these aren't CO2H2O, right? That's a single. Whew. All right. I got answer keys and I got questions online for you on Schoology. Hop into the U6D07 types one and let's try some out. All right. Hey, then I also got after that a reaction life or types life reaction, something like that. You'll see it. All right, give that one a run too. I think you'll actually enjoy that one. All right, we'll see you on